In this question here, we have Phyllis swimming downstream at a rate of 8 meters per second at a 50-degree angle to the current traveling at 5 meters per second. We want to know how far downstream she'll end up across a 500-meter wide river and how long it'll take her to cross the river. Well, first thing we'll do is draw in her two vectors. This is her velocity vector of her swimming, and this is the velocity of the current. Now, because we talk about her swimming at 50 degrees to the current, her swimming is a vector and the current is a vector, we must place that 50 degrees here when they're tail to tail. Because whenever we talk about the angle between two vectors, it's always tail to tail. We don't have the option in this question of saying maybe she swam out this way, because that would not be a 50-degree angle anymore. So there's your 50-degree angle. Now, what we're going to do is determine what would be the magnitude of her resultant velocity vector. Because here's your 5 meters per second. And we're going to add 8 meters per second here and create a 130-degree angle here and try to determine that resultant, like we've drawn right here. So since this magnitude is 5 meters per second and this one is 8 meters per second, it's not too difficult, knowing that to be 130 degrees, to determine the magnitude of the resultant vector overall. And that magnitude is approximately 11.85 meters per second. At this point, we can determine that angle right there. 11.85 over the sine of 130 is going to equal 8 over the sine of alpha. And we get that alpha equals approximately 31.1 degrees. Well, that's useful for us because now, since this is 31.1 degrees, and we can draw a perpendicular there and say this must be 58.9 degrees. And we can draw that second diagram here. Here's a 58.9 degree angle. We have a 90-degree angle here, and we have a 31.1 degree angle there. And since we know this distance straight across to be 500 meters, we can determine this distance here using the tan ratio in trigonometry. So the tan of 31.1 degrees is going to equal 500 over d. And doing some pretty straightforward math, we see that the distance downstream is approximately 829 meters. So that's how far she ends up down the stream. Now, the question also asks us how long it takes her to cross the river. Well, we have two velocity vectors. One of them is this one, and one of them is this one. Now, it's pretty obvious to tell that the vertical component of this current vector is 0. In other words, the current is in no way, shape, or form helping someone cross the river. It's not helping them cross or hurting them cross specifically. All of that is coming from the 8 meters per second vector. Any verticality in this resultant is coming from this 8 meters per second vector. So what we're going to do is, since the angles are at 50 degrees to each other, we're going to figure out what is how much of that 8 meters per second gets a person vertically. So what we can do is set up this triangle here. We have a vertical velocity magnitude that we're looking for. We have 8 meters per second here. That's like our hypotenuse of our right angle triangle, and we have a 40-degree angle. We know that this is 90 degrees, and so we can say that the magnitude of this right here is going to equal 8 cos 40 degrees, or in other words, approximately 6.13. For those of you who prefer SOHCAHTOA, look at it this way. All of our vertical velocity is coming from her swimming efforts, which are 8 meters per second. Now that 8 meters per second is 50 degrees to the current, which means it's 40 degrees to the vertical. Now, drawing a right angle here, I can say that cosine 40 is the vertical component of the velocity over 8. Or in other words, since cosine 40 is equal to the magnitude of the vertical component over 8, I can also say that the magnitude of the vertical component is 8 cos 40, which is approximately 6.13. Well, at that point, I can ignore all of the horizontal and simply look at the vertical. I know that distance over speed equals time. Always does. Well, that means that distance vertically over speed vertically equals time vertically. Well, the time vertically is going to equal the time horizontally. There's only one time. So in other words, since distance over speed equals time, we can say also that distance vertically over speed vertically equals time. 500 over 6.13 equals 81.6, and the units take care of themselves. So we can say with certainty that she'll end up approximately 829 meters downriver, and that it'll take her approximately 81.6 seconds to do so.